One of the light characteristic or property is the intensity of the light. Let's say we have three sources of light, such as bulb, for example. Number one, that's number two, and that's the third one. The amount of the light emitted by this source of light in this area is the intensity of light. It could be little, so the area will be dark, or it could be a normal amount, or it could be like a lot of light, a lot of brightness. So let's say you're sitting here, you want to read a book, for example. That's you. That's your eyes. So in this one, you cannot read in proper way. It will be dark. This one, you will be like really comfortable. You can read or do whatever you want to do easily. What about this one? The excessive amount of brightness sometimes become like really annoying for the eyes and it's become uncomfortable. So you cannot sit normally with open eye like that. You'll sit like this, closing your eyes like this to prevent the excessive light entering your eyes, because it could be like really uncomfortable. And you want to reduce this high amount or excessive amount of brightness by closing your eyes. This excessive brightness, which could be like really uncomfortable for the eyes, we call it glare. It's a very important word, you should remember it. And it means excessive amount of brightness that making the eye uncomfortable or making the eye sensitive for the light. How can we reduce that problem, the glare problem? To get the idea, we said the light is a transverse kind of waves, which means it's travel in this direction, but the movement of the waves like that, up and down, perpendicular to the direction of the travel. And it's an electromagnetic waves that the electric field and perpendicular, we have the magnetic field like that, something like that. The magnetic field. So if you put your eyes here, of course, you cannot literally see the waves, but to get the idea. So if you put your eyes here, you'll see something like that. That's the electric field. And perpendicular, we have the magnetic field. But the light doesn't come that simple from the source. It will come in a complex way. For example, that's the source of the light. Let's say the sun or bulb or whatever. The light coming from the sun, the electromagnetic waves will be like that. That's the E and that's the M. We will have another E and it's M. And a third one, for example, something like this. That's E, electric one, and its magnetic field. And a fourth one. And so the shape will be like really complex. So here's your eyes. The shape will not be as simple as this one. It will become something like that. The first one, the first electric field with its magnetic. The second. And third one. And the fourth. And there could be the fifth, sixth, seventh, and so. Your eye will see something like that, making the eye like really uncomfortable. So you have to close your eye a little bit. So a small amount of light will enter your eyes because there will be a high amount of glare. Each one of those, we call it plane. So we have this plane, we have this plane, this plane, this plane, multiple plane. We can solve this problem by removing all of those planes like that, making only one plane remain at the end, like this, just this one at the end. And this is the polarization of the light. So polarization or the polarized light waves are light waves in which the vibration occur in a single plane only. Instead of all those planes, you can polarize it into one plane only. This plane could be vertical, could be a horizontal one, could be an oblique one, no problem. But the end is just one or single plane. So this unpolarized light, this one with single plane, only are polarized light. This polarization occurs only in transverse waves such as light. So the longitudinal waves such as sound cannot be polarized. So we have that complex planes of light coming from source of light. It will come like that, as we said, a complex component of planes, out of planes. And we need just one plane to make it comfortable for your eyes. How can we do that? Where there are 4 methods to polarize the light. We can use a filter. That filter made of tourmaline crystal, for example. It's a natural crystal that transmits light in only one plane. So that filter of tourmaline has a slit in the middle, and the other, of course, is oblique. It will be something like this. Big here. With opening in the middle. So when this light will come next to this filter, this area will block the whole planes, the whole light directions. Those different directions of light will be blocked by this filter. So here it's like that, complex. The only one can pass is the vertical plane, only it can pass from here. And here we have the polarized light. The other are blocked by this red filter. We can do it in different directions. It could be, we can put it like that. So the horizontal one will pass, or we can do it like this. Any oblique one will pass, and so. The idea, just one plane will pass. Let's say you are next to the beach, for example, or by the beach in a very sunny day, and here is the water. There you are, with full opening eye. Then the complex light will come right into your eyes with different planes of light, a complex component of light like this. Reflected from the water into the middle of your eye. It will be like really painful. You cannot open your eyes. It will be something like this. Close like your eyes and like you are really, really angry. Cannot open your eyes. You hate the beach now. What you're going to do is wearing a sunglasses. Sunglasses could reduce that problem. And now you are happy again by using the sunglasses. The idea of sunglasses is polarizing the light. So your sunglasses will be with filters like this, allowing just the vertical lines or the vertical planes to pass into your eyes. The other planes, this one, this one, this one, cannot pass into your eyes. So now you can see comfortably, removing all of that glare. So using that filter, which will transmit only one plane, is polarization by transmission. That's method number one, polarization by transmission. And the best filter or the best material we can use it is the tourmaline, which is a kind of crystal. And that tourmaline crystal, we call it dichroic. And dichroic means light with different polarization are absorbed by different amounts, which means absorbing one of two plane polarized components of transmitted light more strongly than the other. Sometimes when that surface of water is almost regular, the light coming from the sun can polarize by reflection, like this. So that the reflected light to your eyes, the surface of water mostly will reflect horizontal plane. So a lot of horizontal plane is going right into your eyes. Well, we have a little bit of vertical, for example, or one like this, a little bit. Mostly they are in horizontal shape. All of that horizontal planes coming to your eyes, that could be painful too. There will be a lot of glare. Right, they are one plane, the horizontal one, but a lot of horizontal planes that could cause the glare also. So you need to wear a vertical sunglasses. If you wear the glasses with horizontal, those planes will pass and you did nothing. You'll still complain out of the glare. But when you do it as vertical shape, just the rare vertical shape will pass into your eyes and that will be comfortable for you. So if you are a fisherman and you want to see fish inside the water, your sunglasses should be with vertical slits or vertical aperture to allow just the little amount of vertical plane to pass into your eyes. Now you can see the fish easily. Otherwise, the reflection of the horizontal plane will hurt your eyes. You cannot see anything inside the water. So the water reflects mostly the horizontal planes. That's the second method, polarization by reflection. We have a complex plane. By reflection, we can polarize it into just one plane. Polarization by reflection, the unpolarized light can also undergo polarization by reflection, but of non-metallic surface, such as water and also mirror, non-metallic surface. Metallic surface reflect light with a variety of vibrational direction. However, non-metallic surfaces such as asphalt roadways, for example, snowfields and water reflect light such that there is a large concentration of vibration in a plane parallel to the reflecting surface. A person viewing objects by means of light reflected off the non-metallic surface will often complain of glare if the extent of polarization is large, such as what's happening here in water. There is a polarization by reflection. The complex one becomes a horizontal, but because there's a large amount of horizontal coming to your eyes, that will cause a glare again. So a fisherman, for example, with this glare, cannot see fish lie below the water. Or those who skiing in snow, for example, a white area, the snowing area, have a lot of glare because of high amount of polarization. So skiing people need to wear a specific kind of sunglasses to prevent all of that glare. The high amount reflection from the snow could cause something we call it the snow blindness. It's like temporary, you cannot see anything. The same idea of polarization by reflection, we can polarize the light by refraction. So the fourth or the third one is polarization by refraction. And we said refraction means when the beam of light changes its direction because different media. And here is the complex plane of light. Most often, the polarization in refraction occurs perpendicular to the surface. So that's the surface. The polarization will be perpendicular to it. The last one is the polarization by scattering. And as we said, scattering means when we have a molecule in the path of the light, the incident light will separate in different directions. Polarization also occurs when light is scattered by traveling through a medium. When that light strikes an atom, for example, that's atom, and we have scattering in all directions. So we have light transmitted in this direction, the same direction of the incident light, the first path of the light. And we have other directions that perpendicular to the incident light. Here we have the incident light with the different vibration. The light in the same direction of the incident light, this one, then the light will partially polarize, which means part of it only will polarize. We will have different direction only. So part of it only will be polarized in this direction. What about the perpendicular? Right, this one and this one. This one will fully polarize the light. So this one partially, and this one full polarized of the light. Polarization by scattering is observed as light passes through our atmosphere. And as we said, that's why we see the sky as blue color. The scattered light often produces a glare in the sky. Photographers know that this partial polarization of scattered light leaves the photograph characteristic by washed out sky. The problem can easily be corrected by the use of polarized filter. As the filter is rotated, the partially polarized light is blocked and the glare is reduced. So instead of all of that blue color appearing in the photo, we can use a polarized filter to reduce the glare of the blue color in our picture by polarization. So four methods of polarization: by scattering, refraction, reflection, and the transmission. So for now, how can we use the polarization? What we need it for? The filter inside the camera, we need it in the sunglasses for the fishermen, for example, for those who skiing in the snow. We also can use it in the liquid crystal display, the LCD screens, such as this one. If you notice here, we have the polarizer, the filter. We also have here a polarizer, but with different direction. In LCD, when we need to show a specific number, we will allow part of the image appear on the last screen and will block the other part from appearing in the display. So we have the LCD working in this principle, that the 8 number, nothing is polarized here. In the last screen, if we need number 5, we will block this area and this area. Or if we want number 3, we can block this area and this area. Here we have these two images, both use polarization technique. The left one shows more glares, if you can see all of those white colors, and to the right, there is no glare. What's the difference between them? Both using polarization, or both using the sunglasses. This one use sunglasses with horizontal shape, which means we will not block a lot of light. The opposite here in the right, we're using the sunglasses with vertical opening. That's meaning we will block a lot of reflected light. So next to the bit, we should wear sunglasses with vertical opening, not horizontal. As we said, the reflection from water will be mostly horizontal, and we need to block all of that horizontal planes. So the sunglasses should be with vertical opening. Otherwise, the image will be like the left side. It's like you are not wearing any sunglasses. But to the right, you are blocking most of the glare. If you look to the image, to the left, the photo without polarized filter. But to the right, the blue is beautiful without any glare because we use the polarized filter inside our camera. So to the left, there is polarization by scattering. We can block that by filter to give us a clear, comfortable blue. We also can use it in cinema while we're watching a movie to give us a three-dimensional image. How can we take advantage of the polarization to use the three-dimensional image? In polarization, we have 3 types. Again, we have a source of light with all of those vibration direction. And we put a filter here to allow just pass through this opening to give us just the vertical plane. So it's a linear one. Or we can use it as horizontal, no problem. Just allowing the horizontal vibrate to pass. Or it could be oblique to allow this one to pass, or in different direction, this one. If you see those lines, they are lines. This one is a line too. Doesn't matter the direction, but it's a line. So this type of polarization is a linear polarization, which means allowing one line, only one line, to pass through this filter. So in this polarization, the linear polarization, the electric field of light is limited to a single plane along the direction of propagation. Just one single plane, that's all. But sometimes we need a different polarization, such as the circular polarization. So let's say in this vibration of light, this different vibration of light, and if we draw the waves, this amplitude equal this amplitude equal this one. The same here, we have the perpendicular one. The amplitude here equal to the amplitude here, equal to this one too. So all of those amplitudes are equal. So back to this vibration, which means the amplitude here equal to this one, equal to this one, equal to this one, all of them are equal. In polarization, sometimes we don't just need one direction or one vibration, one plane. Sometimes we need them all. Well, that again means glare. So we can use a rotation filter. That rotating filter, first time will allow this one to the path. And after that, rotate to allow this one to pass. After that, rotate again to allow this one to pass. So the propagation of the occurring electric field will be in a circular motion. So the filter will not be stable like this one, will not be stationary like this, will keep rotating. The first time it's like this, and after that it will come like that, and after that like this, and then again to this position, and so give us a circular shape. But again, this amplitude should be equal to this one, to this one, to this one. If those amplitudes are not equal, let's say this one is longer, those here are longer, we can use this same idea of the rotating filter, but this time it will be the elliptical polarization. So in linear, we just allowing one vibration to pass, just one vibration. This one, we will use a rotating filter. One time will allow this, the one, the other one, the other time will allow this, and then that one. But those vibrations should have the same amplitude. If not, they have different amplitude, one is short, one is long, then we can use the elliptical polarization. The same rotating filter, but with different heights. How is that useful? Back again to the cinema. Here you are watching whatever movie you like, animation, horror, action, whatever you want. That's your eyes. You are happy about the movie. And they give you a specific kind of glass so you can see in 3 dimensions. The human eyes also observe in 3-dimensional. How? Let's say we have a tree. There is your head, but from above, that's the first eye, and that's the second eye. That's the nose. And that's your ear. So when we close this eye, let's put a barrier, you will see mostly this area of the tree, and also you will see the side of the tree, but you cannot see this side here by the right eye. You cannot. Now, when we close this eye and open the other eye, the left eye will see this side, but not this side of the tree. When we open the both eyes at the same time, by this eye you will see this area, and this eye you will see this area. This slight difference in view will give you the 3-dimensional image. The same idea will happen inside the cinema by using these glasses. So they will give you that glasses. If you remember when we talked about the sunglasses, we said mostly it will be like that, or another kind of sunglasses could be like that. So both lenses with the same direction. But as we said, next to the beach, it should be in vertical shape. That's better to block more polarized light. Well, in cinema, we need to see in 3-dimensional. So the glass will be like this. One allowing the vertical and the other one will allow the horizontal shape. This idea will give you a slight difference in the images between two eyes. So this one will allow the vertical vibration to pass, while this one will allow the horizontal vibration to pass. But that means if you tilt your eyes, if you sit like that, putting your eyes like that, you are tired, you put in your head like that, that means the light will not pass. You're blocking them because you change the direction of the glasses. To prevent that, they will use the circular polarization, which means using the rotation of the rotating filter. So now you can move your head in every direction you want, even if you sit upside down. No problem, you can see your movie as comfortable as you can. Let's have a look at this video. So that's our filter with vertical. And that's the light, look, with different vibration. The filter will allow just the horizontal, the vertical one to pass because our filter with vertical slit. Now we're changing the rotation of the filter or the direction of the filter. Now we have a different direction of that polarized light. It's a line, so it's a linear polarization. If we put another filter with the same direction, the light still can pass. But what if we change the direction of that filter? You will immediately block any light to pass from, because that shape of the or the direction of the light here, of the vibration here, different from the direction of the filter here. So it blocks the whole light. So here we have the electromagnetic waves, the electric field with red and the magnetic one with the blue. Let's remove the blue so you can get the idea in a better way. If we put the linear filter, we will allow just one direction to pass. Look, just one direction. This vibration will pass through this filter, and that's the linear vibration. We can change the direction of the filter, but it's still the linear. That's the circle. Look, it will allow just one direction to pass in one time. Next time, different direction. The other time, the third time, a different direction. But all of them have the same amplitude. If they have different amplitude, one short, one long, now we have to use the elliptical filter or the elliptical polarization. So the same idea of circular, but with different dimension.